Okay, so where are we?
Huh?
Where are we?
Seattle Center, Mini Maker Faire.
What are we doing here?
Doing strange things with electricity and probably shocking a few kids and those sort of things.
Okay. And currently embarrassing yourself a little?
Yeah, that's mandatory.
Okay, show us. What do you have?
So we've got squishy circuits. We've got Arduino-based demos with XP radios and a big RGB sign. And then
we won't see anything on the video. It's too bright.
Too bright.
Yeah.
There's actually sunglasses included in the demo.
Yeah, you can go blind with those
You
things.
can go blind, yeah. We've got a Geiger counter over here, and then we've got a display generator and designer for one of our modules. So let's see what else. We've got thermocouples and fan. We've got games involving motion control or distance sensing.
Oh, Kinect.
Well, actually, it's better than Kinect. It's
Better than Kinect.
Yeah, because you don't have
More
to,
precise.
You don't have to calibrate it. So,
Oh, and you don't need a room that's just as big.
Yeah, you can any distance actually. It works from actually 20 centimeters away. It works.
Oh, so it's definitely better than Kinect.
Better than Kinect. Yeah.
All right. It seems like you have some really dangerous stuff in here. What is that?
It's a glow-in-the-dark candy.
Oh, cool! So it's a kid-friendly exhibit, right?
Totally. This is actually uranium ore, and it's handy with this particular thing right here.
Okay.
So this is a Geiger counter that is normally connected to the internet, except today it's not. And
okay, so those are the guts of the counter.
yeah, so you've got the Geiger-Müller tube here. You've got effectively a light sensing circuit to isolate the high voltage part from the low voltage part. So it's opto-isolated. And this picks up the pulses from the LED connected to the Geiger counter and records over here what's going on and counts the pulses. And every so often, every 10 minutes, normally when it's connected to the internet, it tweets about the current radiation level. So the fun thing here with the uranium ore,
Oh yeah, you can hear it going pop, pop, pop.
is to just excite it quite a bit and see the reaction.
Oh yeah. Oh yeah, we're totally getting irradiated here.
Totally.
Cool.
So tonight, you'll definitely glow in the dark.
And you have a very nice enclosure with this.
Yeah, the enclosure is actually based after a game called
Yeah, well, what else?
Yeah. So
Very, very cool. Okay, so why do we have Play-Doh on this stand?
well, the funny thing about this Play-Doh here is that it's homemade Play-Doh, and you've got the green Play-Doh, which is insulating, like a few mega ohms, and you've got this conductive Play-Doh, which actually is still a little resistive, but far less than this one. So you can do fun things like you can build squishy circuits with it. So here what I did is that I just plugged in, I put a resistive Play-Doh in the middle to insulate from those two sides. And I plugged in some LEDs in there, like this, and put a third one in there. And then when you put power to it, they just light up. There you go. So it's fun stuff for kids.
And actually, the first one is much brighter than the other ones.
So yeah, if you remove LEDs, in theory, you're gonna get brighter because you're drawing less power, obviously. So there you go. Okay, if you turn on more, obviously it gets dimmer. That's it. So you can do all kinds of funny shapes for circuits and motors, and I forgot to bring motors, but yeah, you can anything with that you can power with a 9-volt battery, you can do all kinds of fun things with it.
Nice. All right, so this looks familiar. It looks like the first Nwazet product.
Yeah, that was our first experiment doing electronics, really, for fun.
Stop shaking it.
And maybe for profit. So it's actually a little console powered by an Arduino Mini, and you know, you've got a SD card here, and it loads games, variety of games, dynamically off of the SD card, like Pong, for example. And then, well, if I can play against myself backwards, you know, with two fingers, I can show you. Actually works. Yeah, there you go.
It even has sound.
Yeah. Well, not stereo, but you know. So that was our first.
And lots of pixels. 64 of them.
64 of them. So you can
Wow.
really have, you know, you can do some fancy things with this. But it's
So it's a low def design, but
it's actually the point. The point of it is to teach people about electronics and you know what makes up one of these, and seeing things in a very simple things, but end to end. So from literally the electronics.
Stop shaking it, seriously.
From the electronics all the way to the software, and looking at all the different layers that make up a full system, basically.
Yeah, and
So it's meant for educational purposes.
right, and that it is very low resolution is actually a very creative constraint, because it actually forces you to refine the gameplay to what's really essential, right?
And what you see is what you get, meaning that it's as simple as it gets in terms of a display. So what you send to the display is literally the bits in the order that you see them will show up on screen, basically. So that's the gist of it. It's to teach you the basics in a very, very simple way.
Okay, so this mess of wires and stuff, what is it?
Well, mess is a relative term, really.
It's actually very tidy. I know.
Very tidy, yeah. So anyway, I'm just kidding. But it's you have an Arduino Go microcontroller
And several demos
and several
in one.
demos. Exactly. It's running several demos so that we can actually show 7 different things really that we can do with this thing. It's a very small glimpse into the capabilities of what this thing can do.
Okay, so exactly what do we have?
So what do we have? Well, let's start with the source. We've got a power supply module. You've got a relay.
What is the relay connected to?
The relay is connected to this fan.
All the way to this fan.
Yep.
That is totally out of focus. There it is. So you're going to control that
From the
fan,
yeah.
turn it on and off.
Right, exactly. So the relay is basically responding to a command to turn on or off, and it switches power. This is 110 volts.
So this is the place where you put your fingers if you want to get electrocuted.
Exactly. So this is fun for kids. Very,
Okay.
very fun for kids.
Yeah, so if you want to come to the Maker Faire, bring your kids.
Yeah.
Yeah.
They
will have lots of fun.
Lots of fun. So this is a thermocouple, which actually measures temperature very precisely.
Okay, so if we follow this wire, it goes all the way to here.
Right, so this is the tip of the thermocouple.
Okay.
So this is that part that actually senses the temperature.
Okay, so we'll look at the details of that
Later.
when you do that demo.
Yeah. So we have an SD card here that contains some data and some pictures that we'll use later. We have a touch display module. We have an XB radio that talks to that display, RGB display over here.
That is totally out of focus as well.
Okay, well. And then finally we have a custom module that is connected to 2 infrared distance sensors that we'll use as a input device as part of one of the demos. So the first demo is about measuring temperature and controlling a relay. So here you can see in Celsius and in Fahrenheit what the temperature is currently and the state of the relay. So now, if I grab the thermocouple,
To the screen.
if I grab this, it's going to raise the temperature, and above a certain threshold, it
Oh,
turns
that's
on the
refreshing.
fan.
Yeah.
So if you look at the fan now, well, you probably don't see it, but
Oh yeah.
it's actually spinning and cooling us off.
Okay, so release it.
Okay, now I'm going to release it, and
Temperature is going to fall.
temperature is falling slowly, and when it's below 29,
It stopped.
it stops.
Okay, so what's the next demo?
So the next demo is using the SD card to show some pictures and the capabilities of that screen and vibrant colors of it.
Yeah, it's a beautiful screen actually. The colors are great.
And
And those pictures are nice too.
yeah, a good friend of mine took them actually. Yeah, he's behind the camera right now. It's kind of a specialty of his.
You'll get 150.
Oh, and this is in Seattle.
And this is-
like
yeah.
50 meters from here.
It's self-referential. This is a little further out.
Yeah,
In
that one
Paris.
is right.
Buy the parts as needed. Because, I buy PCBs and like
So
lots of-
it's kind of slow because it's directly proportional to the speed of the SD actually, but it's actually the transfer is very fast.
Right, so those pictures were coming from the SD card
From the
through
SD
the
card.
Arduino to the screen.
To the display. Yeah, that's right. In chunks of 8 kilobytes. So that and it's a fairly big chunk to actually display a whole image.
Okay, so what's next? Basic UI.
Basic UI. Yeah. So it just shows like what you can do at a glance, basically with that.
Oh, because that screen has an API that enables you to draw things, buttons.
Yeah, and buttons and
Shapes.
controls and shapes, and you can make your own stuff. And it's fairly easy to hook up and to detect an event or update the screen while you wait for something to take place.
So it's a great way to create a device that has a nice user interface.
Yeah, so it's got a built-in keyboard, and that you can you can switch to actually special characters and a keypad. So it's a nice way for you to enter data into your project
Nice.
without having to develop this from scratch. So you can customize it, but you can easily put a string in there or numbers and configure your application. So it works in different orientations, obviously, and depending on what your scenario is. And that's it.
Cool.
Well,
So next we have LED marquee.
So yeah, we have a series of 4 demos that use the big RGB LED
Yeah,
screen.
so that's an interesting setup actually. We should get into the details of that. So why don't you fire it up and we look at what it's doing exactly and try to explain how it works.
Sure. So LED marquee is actually using the keypad that I showed earlier, so that you
Okay.
can enter some text.
Like Nwazet, for example,
Yeah.
instead of nonsense.
Oh, okay. Yeah, sure. It's kind of difficult to do in this position. NW,
Their motor shield's also really
A,
awesome.
and Z, and I'm hunting and pecking really here because,
You don't know your alphabet very well.
well, the layout of the keyboard is kind of funky here. Anyway, so you get Nwazet over here, and if I press OK, you may want to focus on the screen right now. And take it. I'm gonna tell me when you want me to hit OK.
Yeah, go ahead.
There you go. So you saw briefly Nwazet,
Yeah.
and then it deleted the screen because just in case people put nasty stuff on the screen, so it deletes it right away.
Oh, because people are like that. And
Yeah, they're gonna try stuff like that. So what it does is that it sends the message that you sent over to the display through the XB radio, and it's picked up by the display, which is also running another microcontroller.
So it's not just a display, it's a wireless display,
it's a wireless display,
which
exactly.
is awesomely cool.
Right.
So you've got an XB here, and if we move over here on top of the screen, we have another one that receives the signal and it sends it to this little guy here, the Netbino Go,
which controls this display.
which controls the display through what are those wires here.
Right.
And inside of the screen, what's inside of the screen is actually pretty interesting as well.
Well, I can show you if you want.
Okay, so let's dismantle that thing.
Here we go. So this is how this is built, basically. So this used to be one single strip.
Oh yeah, you can see the structure here. It goes.
So it's like a snake, serpentine setup.
Snake.
So literally the data goes this way, and so it makes for an interesting memory layout when you want to actually construct a picture. It's kind of
because each line goes the other way.
And it has to be written backwards. It's crazy. But anyway,
why don't you fire something up so that we can see it actually working and you destroy the CCD on my camera?
okay, let's do that. So I have a little showcase demo, but the light is not diffused here, so you're going to see full brightness. What this
and
is.
the little piece of plastic that you put in front is actually very useful because it makes for a softer image.
It actually diffuses the LEDs very nicely, and you can actually see what's going on. But if you back up, you'll get better. A much better view of what's going on.
Nice. Okay, so we've got other demos that use the same setup.
Yeah, so this one, the next one is do some, wrong, there you go. So this one is fairly simple. It's you've got a little grid here that corresponds to each LED on the RGB LED display. So if you pick a color, let's say green, and you put a dot over here, it shows up in real time also on the screen. There you go. And then if I'm going to put a little nose over here, and I'm drawing backwards, so bear with me here because it's not going to be pretty. There you go. There you go, the funny face. You can reset your drawing, of course, and start all over. And do more, and it's very good for impressionist drawings and things like that. I should actually probably move that reset button to a different location so that you don't reset your drawing too easily.
Cool.
So the next one is a game called Capture the Dot. So it's really simple. You use this custom-made joystick here with two distance sensors, right? So this is height and
Cup.
okay. So this you've got in the cups you've got distance sensors, infrared, and they control a little cage on the screen. Maybe you can see this.
Yep.
Okay. So when I move this, I move in height-wise, and when I move this, it moves sideways. Okay. So the goal of this is to put the dots in the box.
Cool. You're good at that.
So yeah, really, I've got a lot of training. And then when people win, we give them little keychains made out of circuit boards that were duds actually. Bad circuit boards, but they make cool keychains.